Um, Hello. So yeah,
Hola.
uh, I was looking through some of the interesting examples, um, and I came up with roughly this plan. Um, and along the way, I was just saying to Aaron, I may have found a flaw in the proposal, but we can talk it out and decide. Um, Soundness hole, that is, that would need to be corrected, having to do with reborrows when I was looking at 47,680 in more depth.
In
Um,
the new proposal.
yes, the new proposal. Um, let's see. There must be a simplified version of this. I don't know. We'll start with this. So first of all, let's look at back push. So what one of the, I'm trying to decide where to start. When we do one of the key things in the Polonius design, so to speak, was that the first starting point, we just have fresh regions everywhere. We just kind of give them unique names for all the places, and they have no connection to one another necessarily. And the problem is this doesn't, or I'll show you in this example. If you're not careful, like sometimes connections between regions have to propagate across control flow points, or else it becomes unsound. And this is an example where that would be the case. And by the way, LQD, well, you'll see this is relevant to what you wrote when we get there.
Just sorry, a quick question. Are you sharing your screen right now?
Oh, you know what? I'm not, but I meant.
Yeah.
Good point. There. Okay, can you see it now? Okay, so here's an example that we'll walk through a little bit. Vec push ref. It's actually a simplified version of vec push ref. We'll get to the full one in a minute. It's one of the canonical NLL examples, I guess. So what happens here is we have a vector, and we have a vector here, and then we take commutable reference to the vector, and we have, or let's move this out for fun. So actually, first let me show you this is kind of what the Rust code would look like that you might actually write. Probably not. Something like this, right? So you have a vector, you have a local variable, you push a reference to the local variable into the vector, and you try to mutate the local variable. And the idea is this should be an error because we still have a shared reference to it, so it's not allowed to change at that time, right? Because this is a use. This drop here is just a call to the drop function, so it's a use of the vector from our point of view. Okay. Stop me if that doesn't make sense. I'm going to assume that does. So then if you sort of desugar vec.push, you'll see what actually happens is that we make a mutable reference to the vector, and we call vec push on this mutable reference. And so if we dig in a little bit more into the types of what's going on here, from Polonius's point of view, then you have this initial vector has a type ampersand U32, a vec of ampersand U32, and this variable p is a mutable reference. Oh, I guess I should use ticks here. And there's actually two regions involved. This one doesn't matter, so I'm gonna leave it as underscore. But it's a mutable reference, which has some region, to a vector, and then this region appears here, right? And so what could go wrong if you're not careful is, oh, actually, let's add one more thing. Let temp equals ampersand. Maybe we'll call this like temp 0 and temp 1 or something. Now it looks a little more like what I usually write. So Right, so what happens when we check this? This is a lone. We'll call this the lone L0. And let's give this a name. And so we know that kind of L0 is, I don't know, how do we normally write this? Tick C. We know that this lone, just because we saw the region itself, is part of tick C. Right? I'm mildly simplifying how this actually works. There's actually another region involved, but that's the idea. And then here, when we call vec push, so importantly, at this point, like the reference is not yet in the vector. So there's the only place that the lone appears is part of this tick C region. And when we call vec push, there's the typing relations will kind of have some effect here. So the signature of push is something like and mute vec of t. That is to say, it takes a reference to a vector of type t and a t. And in this case, the t, it's going to be sort of ampersand tick d u32 for some new d. And so we're going to get some relation, which is like this region C flows into D. D, because the t is shared here, and because the way mutable invariance works, tick D is going to flow into B and vice versa. So essentially, tick D equals tick B. If we simplify this and get rid of this whole D thing, you're essentially left with this. So what we're saying is, somewhat simplified, when you call vec push, the lone L0 will flow from C into B. So at this point, we know that, I forget what did we call this relation that Polonius contains? I'm going to call it contains.
Requires.
Or requires. We should change that. I don't like my names. I'll still call it that for now. So we'll kind of know both of these things. And that means now, okay, but now this is where it gets interesting, because now we don't have temp 0 and temp 1 kind of go out of scope and are dead. And that means that the regions in their types are also dead, B and C. So if we did nothing else but what I'm showing you, that would kind of, we have a problem now because we want to make an error here, and we need L0 to be in scope. The only live region is tick A, and if you notice, we didn't even talk about tick A here at any point. That's because we were all concerned with the regions that occurred in this reference, but we didn't think about there's a connection between the type of the reference and the type of the thing the reference refers to, the referent. Right? And what actually happens is that here, the type of this right-hand side is going to be, so the type of and mute vec is something like, let's just say it's, well, I'm not going to go into the super depth of how this all plays out in the type system, but the short version is that the type of the thing you borrowed, the vector, winds up being equated with this type. They have to be equal. So you wind up with tick A equals, you wind up with this subset tick A tick B and subset tick B tick A, which is equality in our terms. So, you know, tick A outlives, or tick A flows into tick, this way. And so that's where this subset propagation stuff comes in, because in the normal Polonius, we flow these things forward, and then we have down here, we not only know that tick C outlives tick B, but we know that tick A outlives, or that's a hard habit to break. I don't like to say outlives anymore. Tick A flows into tick B, and tick B flows into tick A. So they're essentially equal, which means we get a requires L0 tick A here, because if tick B requires it, then so does tick A, because of this relationship. And so down here, we get an error like we expected, because we have a live region, and we also have that region requires that tick A, or yeah, requires lone 0, and lone 0 restricts modifying X. So that's why this subset propagation is kind of there in the first place. And I think, like when some long time ago just said, oh, I forgot, why do we even have subset propagation? And then Matthew Jasper, if I recall, cited an example much like this one. That was exactly why that proposal was totally wrong. That makes sense?
Yep.
So in your write-up, or the vec push ref example itself is just like a mild variation on this. And in your write-up LQD, you said there are no mutable references, but actually
Yeah, exactly.
they're
They
just,
are in the desugaring, yeah.
yes. So the variation was something like this, if I recall, where basically you introduce a branch and you say you only want it, this side is, in this, when you get here, you're dropping the vector, but in this side of the branch, the vector never comes into contact with this lone. Actually, the lone can be even out here. So the lone is created in both branches, but it never gets added to the vector in one side. And we would like to make sure we know that. And if you work out the way this relation thing works, we will know that basically because although the lone is created here, the connection between the type of P and the type of vec is created here. And so it just works out. So that's how subset propagation works. But if we were going to, actually what did you call the other example? You called it like unnecessary error LQD.
Yep.
We should probably come up with a more descriptive name, a more unique name. But what we were, so let's look at that one then. No, wrong heading. Do you have the example at hand?
Yes, it's linked in the write-up. I can also add the link to the paper.
Oh, that would be great.
Pretty good, yeah.
Okay, so the subset really, perfect. Okay. Yeah, this is good. So what we realized recently, that's the thing I hate the most about paper. Pasting code examples from GitHub. I don't know what HTML magic they're playing over there, but it doesn't translate very well. In any case, this example, so the subset propagation winds up being imprecise sometimes because basically our idea was when you create a subtype between types, the subset propagation says that subtype has to continue forever, essentially. But sometimes you only need an instantaneous subtype. So if you think of the regions as sets of loans, or the provenances, I guess, for changing our terminology, which I'm not going to do mid-call, then you only need the subset relationship to hold at that moment. And that's more in this example, where we have two variables, x and y, and we copy one into the other sometimes. But in that case, like at the moment in which we do the copy, whatever x might point at that time, y can now point at. But if we make x point at something in the future, y still will never point at that, right? But but that's not what Polonius thinks, because Polonius creates a subset relation saying that these regions have a relationship to one another, and it carries it forward. So at this point, it still believes that they're related to one another. So when we add something into x, we wind up thinking that it's borrowed even when it's not. So what we were proposing was that we could change this by trying to be a little more careful, basically, about what subsets we propagate. And the initial proposal was to say something like this. Instead of saying that instead of saying that if you have and mute, or when we came back up here, we said here, I kind of said that these have different letters. The type of vector is tick A, and the type of temp 0 was tick B, but we kind of added a tick A equals tick B relation. Well, what if we kind of pushed that earlier and said, for this to be well typed, they have to actually be the same letter in the first place, the same region. Now we don't have to propagate the equality because when we sort of add things into temp 0, we're actually not adding them into B as before, but we're adding them into A. And so everything kind of just works. And that's true, but it also has problems, I realized. Where is the issue? It can be imprecise in its own way. Oh dear, we have to land your PR, don't we? Well then. So this example basically shows that problem where it's kind of complicated, but you essentially what happens is you create an equality in one branch and you create a different equality in the other branch. So here we have that P has to equal the type of this has to equal A, and here we have that it has to equal B. And because equality is, if we say that that's just true across the entire graph, because equality is transitive, that means that A and B also have to be equal, which means we've lost track of the fact that these are two different vectors, essentially. So now if I push into one of them, like A, and then I drop the B, or if I push into A, I'll also assume that that region lives in B. And so I get an error on one of these two lines, or both, I guess, actually. And so it would be kind of nicer if we said, well, it's only equal, it only has to be equal starting at this point, essentially. Before then, it's not true. And I guess there's another, now that I think about it, there's probably a simpler example that would leverage that, similar to vec push ref. Like, in other words, we're also saying, I didn't even use C, I just put it in here to have some initial value, but actually we're equating A, B, and C all because they're all sort of going through P. So we can probably do something focus. But there's no reason we can't. So what that leads you to is that instead of saying that they have to be the same, like actually the same region, we could do a simpler version where we propagate equality forward across the graph and not all of subsets. Oops. But keeping that in mind, let me jump to a different example. First of all, let me stop. Any questions so far?
Not really.
Okay. Was that no, Alvin?
Yeah, it was a no.
I couldn't tell if it was no or I, and then a hesitation. Okay. Let's look at 47,680 though, because I think I found a problem just 5 minutes ago that I thought was kind of interesting and surprising to me. So the actual, if you actually look at 47,680, you'll see that there's a whole bunch of examples here, some of which are quite complicated. But the one that I like is this one. So this is my sort of preferred form. It's kind of a nonsense program, but that's okay. I mean, it goes into an infinite loop. But what's happening is you've got some linked list or something, and you have this loop, and you're saying, if there's a next pointer, I want to move temp forward. Otherwise, I do nothing. And that seems like it should be allowed. But what ends up happening with NLL today is you get an error. And the reason is that the reason is kind of complicated because we have some logic. The killing rules are, is everyone familiar with the kill rules? Probably, but maybe not. We could do an intermediate step. I don't know if I need to, but basically the idea would be something like, how does this work? Right. I'm trying to think of a good example. The idea is when you modify a, I guess it would be something like this. Maybe we don't even have to go all the way to 4680 to even see the thing I was going to talk about anyhow. But the idea of the kill rules is that when you modify here I have a mutable reference to something, and then I borrowed it into R essentially. I borrowed what it points at, I sort of reborrowed it. And the point is that in this period, I can't use Q because it's reborrowed through R. But if I overwrite Q with something else, now I can, right? And that should be okay. And the way that we figure that is that we create a lone, let's call it L0 here, and that's a lone of star Q. And that lone is in scope because R is live. But then here, we basically kill L0. We say, okay, that lone no longer applies. And the reason is that the path that was borrowed, Q, is now a different value, right? It doesn't apply. So it's kind of like an SSA transformation in some sense. Or it's if you had done SSA, this would be a different name now, sort of Q1. But that's what the killing does, and it's important here because when you call maybe next, you're borrowing temp, and then you're taking the result of that borrow V, and you are making it live across the loop. So the borrow of temp is still live when you come around the loop. The only thing is temp now points at something else. Right? And so we kind of lose track of that in the current NLL. We see that the borrow is live around the loop, and we report an error even though temp was assigned in the meantime. And part of that is because we can see that temp gets assigned here, but we also have this, we have two separate things. One is tracking the control flow and seeing that we're going to go back around the loop, and the other is doing the kills, and we don't see that in the control flow, or we see there's one path where temp does not get modified, and there's one path where it does, but we don't see that in the path where it does is also the one where the subset occurs. That's the thing. The data only flows into it if it's also going to get modified. We can't keep track of that. We just know the data flows in, and sometimes it doesn't get modified. So the thing that I was concerned about, let me see, I kind of simplified this to what it looks like to go on.
This is not the soundness hole you were mentioning, right? Because this is a completeness issue.
Yeah, so let me see if I can make a simple example of the soundness hole before I come back. I think that's the most interesting thing. And maybe soundness hole isn't quite right. Basically, my concern was around here. So what we do, at least today in Polonius, if you have let's see. How would this happen? Maybe it's not a soundness hole. Maybe I'm wrong. So if you have, what we do here, let's leave this aside. When you reborrow Q, when you borrow the referent of Q, we introduce a relation that says, that A flows into B. And the reason is, if you think about it, it must. Like the only reason that this reference R is only usable because like the data it's pointing at is this X, which is the same X that Q is pointing at. So whatever loans sort of secure X also secure B, right? So we introduced this relation, and this is what I was concerned about, was that now this is like an instantaneous relationship, and I was worried, but maybe I'm wrong, that if you later made changes, no, I don't see. Maybe I'm incorrect. I was worried that that this relationship should be persisted. Is that true? I guess it's not true though. So maybe it's not a sum result. Maybe it's all just fine.
So the analog in Oxide would be basically that we do this flows into and don't really create a loan for dereferences to places. So we don't need a kill rule because we don't make that loan L0 of derefq. We just flow all of the information from A into B.
Does that what stops Q from being usable?
That Q has the same set of things, like that those loans are elsewhere, I think. Maybe that's a little bit confusing to say.
Okay, I don't remember well enough to recall.
It's like we have a judgment that's set up that prevents you from like using a mutable thing when there are other. This might actually be a problem thinking about it, because it might actually prevent you from also using R without saying sort of implicitly drop Q or something.
Right. It seems like there has to be something that says R is the one that wins, so to speak.
Yeah, I'll have to look at that.
Okay. Well, maybe there's no soundness hole, which is good. But if there is, it has something to do with the fact that this should be persisted. And if I can think of it either while we're talking or later, I'll decide. I was going to just sort of play through how this example works out, which I guess I might as well do, unless people don't want me to. It's kind of interesting. And this is like a mildly simplified control flow graph for what happens up here. In particular, I kind of elided the whole matching, just made it the whole option logic essentially goes away, but it's not really relevant. So it's more like as if maybe next returned the same thing it was given and you randomly picked to assign or not assign or something. But you got, right, so you start out with this variable temp, and then in the head of the loop, B1, you borrow from temp, call maybe next with that borrow, and then take the result and sometimes assign it to temp and sometimes don't, and come back. And what winds up happening here is that we, right, so we would, if this guy's type is this, we would say, okay, L0 is in tick B, tick B flows into tick A, or not yet, L0 is in tick B. And how did I write that? And here, tick B flows into tick C, yes. And here, tick C flows into tick A. but we can kill L0. Go to B4. Okay. Those are the basic relationships. And so what you wind up with if you propagate this through is that, there's something missing. Oh, right, there is this. This is correct. Because we borrowed star temp, so we have that relationship between the mutable reference that we dereferenced. That says B is dependent on all the things that A is dependent on. So A flows into B. So we get down to here, we have, here we know that transitively, if tick A outlives tick B and tick A outlives tick C, so we kind of know both of those things here, but we kill L0. So we had, until we killed it, we had that L0 was in scope for all that code. And when we get to B4, we have that, or at this point, we sort of have that tick C outlives tick A and tick A outlives tick C. But because temp is no longer, because P and T go dead, we can just kind of remove all those relationships because it's a dead region. And so when we cycle back around, we wind up with really nothing, I guess. No subsets and no requires. Well, apart from this one, which I'm ignoring. And that's the idea. If we, I'm trying to think why I thought that was exact. I must have just been mistaken. I felt like it was important to keep in mind that P and temp had this relationship to one another. But it seems like it's not, because you kind of can't access temp, and if you modify that region in P, you've just made it point somewhere new. You haven't modified the thing that was pointed out. That's the whole point. So yes, okay. So I still think it's probably okay, and I think equality propagation is probably the thing we want to do. I haven't looked at Remy or LQD's code to see why it's taking forever on clap or whatever, but there you have it. Any questions? Any thoughts? Or are we done?
And how does this relate to Oxide's model? Because the last example you mentioned, you were asking Aaron whether it would work in the Oxide model. How close are those two models?
That's a good question, but Aaron should answer.
Yeah, this is a good question. I think they're fairly similar. I think the main difference that I'm thinking about right now, because of the question that I asked, is that I recently, maybe a couple weeks ago, did a change such that loans can only be for sort of place values. So I made like a value expression distinction where place expressions can contain dereferencing and place values cannot. And you can only have loans for place values, which now that I'm seeing some of this stuff, I'm not so sure. So maybe like that's a current gap, and it might be a gap that I have to close by doing what Polonius is already doing and allowing loans against dereferencing.
I think a core question, like an intuitive difference, which is what gave rise to this whole discussion, is the question of, can you capture the current state? Like if you just look at any given point, if you just look at the requires relations, which is kind of the value of, if you think of regions as sets of loans, that's the elements of the set. Could you just replace all the regions with the elements of their sets? And the answer
Oxide is doing that.
Right. The answer in Polonius is no, Polonius today, because there's also these subset relationships, and they're important. If you just replaced it with the set of loans, you would lose the connection between temp 0 and vector, right? And that's exactly why we were saying, well, maybe if you just required them to be the same name,
Right.
then you could, which would be this stricter rule. But now I'm not sure what the answer is around this if we do the sort of location-dependent equality. And Aaron, I didn't quite understand your response actually about how that would work. I guess it depends on details.
Yeah, I think it's quite dependent on details, but I guess the gist of it is sort of that uh, you can have the type of P be different, like the provenance variables in it be different. But once you go into, like when you go into one branch, you'll do some like unification in the assignment. That's basically going to be a strong update to the type, but the only part of the type that it can change in that strong update is the provenance information. So it can add more loans essentially to the set of loans for the provenance of P. And so that happens in each branch, but because they get dropped, there's no question of, it's sort of at the end of each branch, we try to unify the information we have to get like a conservative bound on what's allowed in the remainder of the program. But because we drop both A and B before the end of each branch, there's nothing, it knows that it doesn't need to unify those pieces of information.
Yeah. So the key thing here is you can replace them, if I can restate what you said. You can replace the regions with or the provenances or whatever with the set of loans, but the variables don't have a single type. They have a type that's changing across the control flow. And so a strong update, which for those who, I don't know if everyone's familiar with that term, means changing the type of the variable basically. We're going to kind of change the type of A and P here and change the type of B and P here to be equal. But when we unify the two paths, in this case, there's no sort of, they can all go away. But if there were further uses, we would force them to be equal.
Yeah, exactly.
And
so if the program, allowed these to live out of the branch, then we would have to, like, say there wasn't the drop B and the drop A, right? Then you would have to act as though, and I guess you also wouldn't be able to have the I plus equal one, but
you could have
to treat P as if it was A or B.
You're right. Yeah, you could. Yeah. So I think the equivalent in Polonius, like if we're propagating equality, then in a sense what we're saying is, no, you can't just replace it with the requires, but what you could do is sort of canonicalize the names, taking into account the equality relations. You could pick fresh names, where for things that are equal, they have the same name, and then replace those names with the sets of loans, and it should be fine. You haven't really lost any information. I think that seems correct. That's just true. Like you keep the equality information because now you have the same name, and you keep the once they have the same name, they'll have the same value forever. Kind of.
I think something interesting to note about the like strong update part, like type updating, is that actually I think the types never. It's kind of weird that the types themselves don't actually change anymore in Oxide. What happens is that the types, which all contain these like provenance variables, the same way that Nico has been writing them everywhere. It's like tick A's and tick B's and whatever. What the meaning of those tick A's and tick B's changes because the set of loans in them grows or shrinks as things flow through the control flow graph. So it's sort of like the interpretation of the type changes, but the type syntactically remains the same.
Yeah, so I'm a little bit, so there's kind of like, you have the type, and it's similar to Polonius in some sense. They have types, and then you have the value of any given, a mapping from the region to a set of loans.
Yeah, exactly. And we call that a loan environment.
How that, if that's true, I don't quite know how the strong update story plays out, but I have to look. Like, if A and B start out with distinct types and they have to wind up with the same equal types, when the controlled flow converges again, then it seems like you either need to keep the relationship between A and B somewhere or change the letters. Does that seem true?
If A and B are the provenance variables on the
Right.
variables A and B, then they shouldn't need to because they're sort of disjoint, right? Like I mean, they're disjoint in the program. Like it's P that's going to need, like the one in P, yeah, that's going to need to contain in the true side of the branch all the things in tick A, and on the false side of the branch all the things in tick B.
Right, and on the merged side of the branch, at this point, we no longer know.
Right, P does.
Well,
P doesn't survive, right? Because you drop the thing that, in each branch you drop the thing that P is pointing to. So P can't.
Yeah, P doesn't survive in this example. I'm trying to think. There's another one. It could survive, right?
Yeah, if P does survive, then we do have to have it have the same type at the end, which would have, like, say somehow P survived in the example you just had, like P would have to contain the loans from tick A and the loans from tick B, for sure.
Yes, but
I don't know how you could, like, if P does actually survive, I don't think you can get around that. I think you do need to treat P as if, like, conservatively, as if it was either of them.
right.
Is that,
I mean,
I guess that's the example you're writing.
Yeah. It's more, I'm wondering, like, you know that B doesn't contain any loans here.
Yes.
And you know that similarly here for A. And I'm not sure how Polonius knows that. I don't quite understand how Oxide knows that yet. I don't know if it matters either. I can't.
It's basically that they're initialized to be empty, and then no changes have happened. Like in the first branch, no changes have happened that would cause B to contain anything.
Right. But what did happen was that P and A were equated.
Yes.
And what here happened is P and B. But equated means only that they have to have the same letter. Or it does. We don't change the letters.
Well, here it's not going to do anything to the letter. What it's going to do is it's going to say that all of the loans that are in A are now in P as well.
So we need to make sure that when
same for B and
same for here.
Yeah, on the other side, it's going to be the same. But all the loans in tick B flow into the tick P.
Right, but you definitely want. So what I'm trying to figure out. Okay, so is here it comes together. It doesn't really matter whether P is live or not. I guess you want this to be an error, right?
Mm-hmm.
And
well, if you drop P, it shouldn't be an error, right?
Why not? It was pushed.
Oh, true. Okay, yeah. Well, because if you drop P and B and A, it should no longer be an error.
Yeah, but if you just drop, this is basically
exactly
the same example as the very beginning. I guess what I'm trying to say is if they're not forced to have literally the same letter, then I don't know how this information propagates. And if they are forced to have the same letter, then it seems fine. But then they have it here, like A and B have to be equal somehow, right? So something has to change. Am I confused? Like there has to be some other mechanism that it's not enough to instantaneously equate them here. That's all I'm saying.
Yeah.
So what is the mechanism that pushes that forward in time? If it's not strong updating the type to have the same letter.
We might actually do a strong update to the letter of the type.
Okay. Because that would make sense to me.
It might be set up backwards, so it might make P have A, which would potentially, well, no, actually that would still work out fine, because then when you reach the end of the branch, you would replace the B with A, so it would still work.
Right, so you could sort of force P to have A's type, as long as it can be dependent on the location, you can force it to have A's type here and B's type here.
Yes, yeah, and I think that's exactly what happens. It's gonna combine the provenances, so tick P will still exist and contain the same loans, but it'll actually, I don't know, I think we should actually have it delete tick P. We're replacing it with tick A.
Anyway,
This is something a little...
Yeah, we can dig into that, I guess. But it seems like it has to be, the fundamentals are there has to be something to propagate equality relations forward. And there has to be, the state is maintained in equality plus sets of members. And you want that to be fine-grained.
Mm-hmm.
That, I feel like we kind of geeked out there. I don't know, I hope everybody else may follow along okay.
Yeah, I mean, I think you actually put, to directly answer LQD's question again, I think you put it the best way, is that Oxide is currently trying to just track the actual sets and do type updates accordingly to make things actually work the same way. Accept the same programs, but that's the...
Yeah. All right. This was awesome. I hope it's awesome for me.
Awesome for me too.
I'm glad I didn't actually find the sound as well. I was going to be kind of depressed.
Yeah, I mean, if there is one, I'll probably find it in a couple weeks.
Yeah, we didn't find the absentee one either, but cool. Talk to y'all later then, and we'll take a look at this. I'll take a look at the work you did, Remy, and also we should land the brightness now.
Yeah. Thank you, everyone.
Goodbye.
Bye.
Bye.